Friends, very good morning to everyone. We were dealing with the preparation methods of carbenes. The two major approaches are polar approach and isopolar approach, along with decarboxylation of the metals or metal salts of carboxylic acids, and by these corresponding aldehydes and ketones can be converted into sulfonyl hydrogens and which can be decomposed to give rise to corresponding carbenes. With this background, let us move to the reactions of carbenes. The carbenes, as their electron deficient neutral carbon species, it can adds on to the double bond or triple bond or any multiple bond, and it can undergo addition reaction, or it can get inserted into CH bonds and other bonds. If not addition, it can undergo insertion. If insertion is not there, then it can undergo rearrangement reaction. Addition, insertion, and rearrangement reactions are the three varieties of reactions a carbene can undergo. For example, I take an alkene and treat with diazomethane and heat it, or uh, pass on the UV light. It gets added upon the carbon-carbon double bond and it gives rise to formation of cyclopropane. The carbene in either in singlet state or triplet state, S and T represents S singlet and triplet respectively. It can get inserted into the carbon and it can give rise to chain elongation, or it can undergo rearrangement reaction by 1, 2 alkyl shift or 1, 2 aryl shift. Aryl is having a more electron richness, that's it has more probability of shifting, that's why 50% of it can be aryl derivative and only less percent will be alkyl shift can occur. Here, this methylene which is formed, a carbene which is formed, its behavior, whether it undergo addition reaction or insertion reaction or it can undergo rearrangement reaction. This, whether it undergo addition or insertion or rearrangement depends upon various factors. It depends upon the precursor from which the methylene or the carbene is generated. The wavelength of the UV light what we use also directs which reaction it can undergo. Generally, the carbenes reaction can undergo either in liquid phase or gaseous phase, and preferably in the presence of an inert gas. Methylene, a simplest carbene, is the most indiscriminate reagent. Why it is so indiscriminate? Because it can get added up across the carbon-carbon double bond and it can give addition reaction. Or it can get inserted and give a chain elongated compound. Or it can undergo rearrangement. It can undergo all three. That's why it is called as most indiscriminate reagent in organic chemistry. It can add up to the multiple bonds like double bond or triple bond, even with a pseudo double bonds in benzene. Or it can get inserted into CH bonds. If I take cyclohexene and treat with either diazomethane or a ketene and pass on UV light into the mixture, I'll get 40% of the cyclopropyl product, and other inserted products, or the mixture of products we will get. Why this mixture of products? Because it is the most indiscriminate reagent. It can undergo addition, it can undergo insertion, or it can undergo rearrangement. That's why we get always the mixture of products. If we want a single product, what we should do? We can control the reaction conditions. I take cis-butene and treat with diazomethane in liquid phase or under high pressure. Then the major product is formed in which the configuration of the original compound is retained, and other products, trans products, can also be formed, but that will be the minor product. Instead of cis butene, I take trans butene and treat in the similar fashion with diazomethane under liquid phase or under high pressure. The major product will be trans cyclopropane, where the original configuration of the butene is maintained, and other products will be the minor products. Instead of using liquid phase under high pressure, if I reduce the pressure, if I carry out the reaction in low pressure under inert atmosphere, then I'll get the mixture of products in equal amount. Means at a low pressure, there is little selectivity. If I take trans butene also, I'll get mixture of trans and cis products. Here some amount of selectivity is achieved. There are like major product is here. When the high pressure is there, the configuration is retained. When low pressure is there, the mixture of products, the major and minor, what we say, the inverted product and the retained product will be formed in equal amounts. When I use transition metal like copper, then I'll get, if I take cis butene and treat with diazomethane in presence of cuprous ions, it gives specifically the product from which it has been and its configuration. If I take trans butene and treat with diazomethane in the presence of copper salt, I'll get the trans derivative only. The original configuration is retained in the product also. Hence, by optimizing the reaction condition, I can get the specific product or I can increase the selectivity. That's why the methylene is called as hot methylene. If there is higher energy and higher pressure, the reactivity is higher. When there is reactivity is higher, the selectivity will not be achieved. When I reduce the temperature or pressure, the energy is lower. And because of this low energy supply, the reactivity will be lower, then selectivity can be achieved. Let us look into further things. If the carbene is in singlet state, the reaction occurs in a single concerted step like S into mechanism. If the carbene is in triplet state, then the reaction occurs in two steps. It is a radical pathway, we call it as. Let us look into it. If there is a singlet carbene, as we know that in the carbene, the electrons are paired and they have the opposite spins. They are anti-parallel. The one electron from the Pi bond forms the bond with this electrons. Pi electrons moves onto this carbon. It donates the electron. A carbene ion is found minus. And once this electrons moves over here, this carbon will become plus, and this minus and plus they combine together, and an intermediate is formed as a cyclopropyl group, and fastly the reaction completes, and the bond formation from carbon and carbon, bond breakage between C double bond C, and the second bond formation carbon carbon occurs simultaneously. Thus, there is a retention of configuration of the original alkene. If at all, if it is a triplet carbon, as we say, triplet carbon is a diradical, it follows radical pathway. The one electron from the free radical, it combines with the one electron from this C double bond C. One electron it donates, and this they are antiparallel, they form the bond. By collision, the spin of the two carbons changes, then the retention of the configuration is achieved. If collision do not occur and spin of the inversion do not take place, the carbon-carbon single bond it rotates. Once it rotates, these which are parallel, the electrons which are in parallel to each other becomes anti-parallel. Once they become anti-parallel, then they can combine together and it forms the product. Here there is an inversion of the configuration due to single bond rotation. That's why we get the mixture of products. Here the spin inversion takes place because of collision, or the inversion takes place because of the single bond rotation. When single bond rotation occurs, change in configuration is there. When there is no only spin inversion by collision, there is no change in the configuration, and the configuration of the original alkene is retained. That's why two products can be formed. And which product is found in major quantity depends upon the reaction condition. Higher pressure, lesser selectivity, and a major product will be formed, where retention of configuration is seen. When lower pressure, lower energy, then there is two products are formed. It can undergo insertion reaction. The carbene added across carbon-carbon double bond to form addition products. If it adds across carbon-hydrogen single bond, then insertion occurs. The carbon and the singlet or triplet state carbene, they can form bond with this when there are a spin of the electrons are anti-parallel, and then the hydrogen, with hydrogen also the electrons can combine with this carbon, and intermediate of this can be formed, and the carbon hydrogen bond here breaks, and carbon hydrogen bond and carbon carbon bond forms, and it gets inserted between the carbon and hydrogen. If it is in the singlet state, then the carbene insertion occurs across the carbon hydrogen bond in a single step like this. If at all this is in the triplet state, as it is mentioned as T, the one electron from the carbene combines with one electron of the hydrogen, and it gives rise to methyl radical and tertiary butyl radical. Then this tertiary butyl radical and methyl radical, they can combine together to give rise to a bond between carbon and the carbon, and the tertiary butyl carbon and the methyl carbon, and it gives rise to an inserted product. The singlet state, if it is there, it undergoes single concerted step insertion. If it is in triplet state, it undergo with two steps. But both the way the insertion occurs, whether in singlet state or it in triplet state. This is the mechanism behind the insertion of the carbene into the carbon hydrogen of the alkyl group. Now, overall, the conclusions are like this. It can undergo intermolecular addition or intramolecular addition. If not, it can undergo insertion reaction. If there is possibility of intramolecular addition, then intermolecular addition do not occur. The intramolecular insertion reactions are more selective in nature than that of the intermolecular insertion. And which is the product formed? It depends upon the proximity of the carbene towards the carbon hydrogen bond. In case of intramolecular, they are in more proximity. That's why there is more selectivity. And the product formed will be intramolecular product. Addition and insertion reactions are the competition reactions. Addition reactions are more easily formed. It is 10 times faster than the insertion. When there is nothing to add up, then it can undergo insertion reaction. Generally, addition predominates over the insertion. This is the two reactions which the carbenes can undergo. Let us look into the rearrangement reactions in the next presentation. Till then, have a nice day.